Hello everyone, today I'm going to be covering this Pacman game with C++. So game design. The basic game board starts off with a matrix of characters that are either periods, basically the empty spots, hashtags, which are the boundaries, E, which is the exit, M, which is a monster, and G, which is gems. And we have A, that's the Pac-Man, which is the player that the user is playing as. So we'll have a main game loop that runs until the Pac-Man has either reached the exit or gets eaten by a monster. Within the main game loop, there will be a series of functions running that take the player's input, make the move on the board, and then check if the move is invalid or if the game is over yet. So basically, what the thing is that the setup game sets this board up. Then you have this main game loop, and also you have this draw screen that keeps on outputting the board for the player. And then you have the get move, which takes the player's input, and then make move, which makes the move on the board, and check end game if the game is over yet. And there's all is valid function that always checks if the move is valid or not. And Pac-Man must collect all the gems before reaching the exit, or else the game is invalid, meaning that we have to keep the count of the gems the player collects as well as the total amount of gems. Now, as I explained the function, setup game sets up the maze and identifies the positions of A player, E exit, and G gems, because it's important to keep track of A player as a global variable as well as E and G, because when you're trying to see if A reached E or A reached a G, as then you have to see that is this the position, is the positions the same, is row A and call A equal to call E and row E. And so that's basically what we need to find throughout each move. So we need to make the global variable and initialize it in the start of the code. And then we have draw screen that outputs the maze after each turn, as well as the remaining gems the player needs to collect, because it's important that the player collects all the gems before he reaches, or he or she reaches, the exit. And there's an isValid function that checks if the player has reached a boundary. So there's boundaries, or reach an exit without collecting all the gems throughout the conditions. Now get move takes in the player's move and moves A. Basically, you know how normal Pac-Man works. You can move the character around. Here, you're gonna type either the move, like let's say R is for right, L is for left, D is for down, U is for up. So you have to make that move, and then that will basically change the position of A accordingly on the board. So this also applies the isValid function to check if the move makes A pass the boundary. So on get move, we have to check is valid before we pass after taking the input, because once we take the input, we need to see if it's valid or not, and then reach the other functions and go on with the main game loop. Or else it's going to just be an invalid move on the board. And make move increases the gem count if player reaches G, exits the game if player reaches M, and always updates the position of A on the board. And as you can see that in the draw screen, it outputs the maze after each turn, so the player can see how the Pac-Man or A moved. Now check endgame checks if the game is over or not with the conditions, basically, in the main window. And it uses a flag variable finish, which I'll cover in the code right now. So here, this is the code. So here you have include iostream using namespace std. Now here the global variables and arrays. So basically we have int n m, which is size of the board, string maze 20, which is the size of the size 20 is the maximum size of a board, and maze is the basically the maze that Pac-Man is trying to get through. Int row am, call am the alphabet's position, int row exit, call exit exit position in the maze, and row target, call target, the new position after the move. So basically, we want to check is row we want to see if row am and call am plus something or minus something referring to the move. Let's say if up, it would be row am minus 1 and call am. And then we need to check if that's valid, and then only update row target to row am and call target to call am. And at the end, we'll reassign that row am equals row target, call am equals call target. Basically, call target means a new position after the move. Int finish is 0, which is the status of the game. Cur move is the player's move, and we have the total gems and int current gems. We always need to compare them to see if they're equal, and then only the player can go through the exit. Here, Eden is 0, which is on a flag. And so here, I'll explain the setup game. As we see in a slideshow, it prompts the player for an input of the size and an M. So here we have the maze. So here I'm asking the user to print out or input a maze. And here I'm seeing where the positions of A, E, and G are. So here I'm iterating through the matrix through I and J. And then if maze ij equals to A, if maze ij equals to E, if maze ij equals to G. And then I'm updating I and row AM and call AM, row exit, call exit, total gems with ij, and here once it's G, the total amount of we need to find the total amount of gems. So total gems plus equals to 1, and then we have finish to -1 because the game is continued will continue to go. Now draw screen just basically outputs the maze remaining gems and the line. Is valid function sees if maze xy, meaning the let's say any move, right? Any move is either reaching this hashtag, which is a boundary, it'll return 0. If it's reaching an exit, but the total gems minus current gems is not equal to 0, meaning the player hasn't collected all the current gems yet, no, all the gems yet, then we'll also return 0, and else it's valid, meaning it's a return 1. And we'll use this is valid function a lot in this get move function. So we have a while loop. And then while true, we have if cur move equals to 0, equals to u, up if cur move D, cur move L, cur move R, which is all the moves, and is valid. Up means that you're subtracting 1 from a row. Down means we're adding 1 to a row. Left means you're subtracting 1 from column. And then R means you're adding 1 to column. And notice how we're using row AM and col AM and not updating anything yet, because once we update it, then we can change it later, and then it'll do it invalid and wrong outputs that the player actually wanted to maybe have made a different move, which is valid, but just a waste of a turn and an invalid move. So here we if this is true, meaning this one means, as I covered in the is valid function, meaning it's valid, then only we're updating row target, call target, as you can see in each condition, and we're breaking out of the loop because we don't need a prompt the user for another move. And if none of these are true, then we basically see that that is valid is 0, return 0, and then that means that we have to see out invalid move. And now make move means that if maze row target call target equals to G, maze row target call target equals to M, and if Eden equals to 0, and so that those are checking if this is true. That means that the player has eaten a gem, meaning the current gems plus equals to 1. If this is true, that means the monster has eaten the alpha man, and so that means it's Eden is equal to 1. Maze row AM, col AM is always an empty space after that, because it's basically A disappears off the board, or G disappears, whichever whichever works, because if a player collects a gem, that means that that spot will no longer be a dot. So if Eden equals to 0, meaning that this hasn't been true, then we only update it. Row target, call target equals to A. And so row AM equals call target. And now notice that now we assign row AM and call AM to row target, call target. And that's why we have this row target, call target value, not just row AM and call AM. So in check endgame is pretty simple. If row AM is equal to row exit and call AM equals to call exit, meaning that it has reached the exit, then we return 1. Else, if Eden equals to true, that means that the player's lost. That means we'll return 0. Else, we'll return that the player is still continuing in the game. And now with the int main function, we'll have setup game, main game loop, and that does draw screen, get move, make move. and finish is set to the value of check endgame. And so it just checks if a game is finished, and we have to break the loop. Here at the endgame information, we output the maze, and we output the remaining gems. And then if finish is equal to 1, meaning that the player has reached the exit with completing all the gems, then we say congrats, you finished. If finished is equal to 0, meaning the monster has eaten the player, then you lost. And if the game is still going, this won't even execute because the main game will still continue to go. So here I hard coded one not hard coded necessarily, but like prepared one maze for us to try here. So now let's enter size of board. The size of the board is 6 by 7. And now let's enter the maze. So let me just copy paste each element here. It's the first row. That's the second row. Okay, so now it read that it's the size n by m. So now let's make a series of moves. So let's say we have our A is right over here. So let's go right. Okay, so we're getting closer. Now let's eat a gem. Okay, so the gem has disappeared. It's taken the position of A, and we see remaining gems has decreased by 1. And now let's go up, which will be invalid move, right? Because it hits this hashtag. So now let's go another right. Let's go up, and then let's go up again, another gem. And now our remaining gems is 1, so we're almost done with the game. Now let's go left, I think. This is an invalid move, and you know why? Because since even though A has reached the exit, it hasn't eaten all the gems because there's 1 gem here, and you see the remaining gems is 1. That's why it's an invalid move. So now let's do another left. And that's also an invalid move because that's a hash, and because it's the same exit. So we could see that so that this proves that the alpha man stays in the same position, and that's why we have the row target call target, because we won't update the row am call am easily if it's an invalid move. So now let's go down, right, down, and now then we lose the game like this. And now let's say we okay, this is the losing condition because we've been eaten by the monster. Now let's say we have had a winning condition. So it might take a little time again, but it's okay. Let's do this. Here I'm just basically showing you the winning condition. Then we have it under boundary set. Okay, so now let's go right, right, and then let's go right, up, up, right, up, down, left, left. And here we finish because our remaining gems is 0 and we've reached the exit. So that's basically how the game works. Now let's go to the conclusion page. So here, Pacman is a very interesting and slightly complex game that involves solid understanding of indices, loops, as well as matrices. And you saw that the conditions that we used for indexing in the isValid function were you use basically basic concepts of indices that are very important for C++. And yeah, this was just a basic version of the game with C++ using many important concepts. Thank you for listening. Bye.